Recording. All right. Today, 122, we're talking about random sampling versus sample bias. And really, what we're starting today is the start of, again, that big idea here that we need a population to be represented by the sample. The sample has to be representative for it to apply to the population, right? So there's clearly going to be some samples that you shouldn't choose if you want to know information about a certain industry or whatnot, like the dairy industry. We don't ask vegans about the dairy industry. Customer satisfaction, 0 satisfaction. They write 0 for everything. But how we create the samples is what we're talking about today and tomorrow. It's the main thing. There's 4 main ways to create a sample. The one we're going to talk about today is just the simple random sample, SRS, from here on out. Simple random sample. Okay. Then we're going to have cluster, stratification, or stratified, and the last one, last but not least, didn't forget, the last but not least is systematic. I hadn't seen that one for a while. But these 4 ways to make samples are the main safe ways to do it. There's also something called the convenience sample. And when people do things out of convenience, do you think it's very thorough? Not really. Convenience samples can be helpful for like getting broad, general ideas about things, but it isn't not a lot of time has been put into it. You know, it's convenient for time, for energy, for everything to collect the data. These are the main ways we're going to do it. So, sample bias. Your data outcomes are influenced by bias. Okay, doesn't provide a representative sample. Now, a lot of stats people also work in teams because one person's idea of what sample or what sample to look at may be biased just by their own experience, right? Like if I was trying to get information about homeowners on my block that I live on, right? If I was doing more of a convenient sample, I'd say, well, I'm just going to ask my neighbors and the people I know, right? What might be a problem with that? You know, I'm in my 30s, maybe I only know people that are kind of young to middle age. I don't know any of the old folks maybe on the street. So you can see that even your own experience will bring in bias. That's why it's good to work together and also go with these type of samples. So I do want to bring up a couple things. I'm going to be turning on and off the projector quite a bit through this lesson. So let me just show you one thing. I'll talk about this and then show you that. So sample bias is really versus our SRS because this is the best way to get data if you can do it. It takes a little more energy. But all outcomes or data are equally likely. The subset that you're pulling out, the sample of the population without bias. So it is a subsample of the population. It does not have bias. Okay. How? Number every possible outcome, then use a random number generator. Okay. Who remembers from last year we were playing 21? We had all the cards on the board, remember? We had the sticky ball here, and each person's time to draw a card, they would throw it to pick our card. We were doing probability games a lot in Unit 4. Okay, so why is that not, or why is there still bias to that? So the cards were pretty much all the way here to all the way here. What is making that having an aspect of bias? Yeah?
Because like wherever you throw it, like that general area will be like thick, so.
Right. If I'm aiming for a card up here, it's more likely I'm going to hit something in that area than down here. Okay. Also, how you can throw, numbers you like. You know, these things I like the number 7, so I'm going to go for 7. You know, there's so many things that are personal preference that go into bias. We just want to be careful. This was, choosing those cards, and we talked about it then, was not a random sampling. It wasn't like picking it out of a deck, right? But since I'm going to talk a little bit about probability, I'll pause for a moment. How many cards in a deck? 52 cards in a deck. How many kings in a deck? 4. What's the probability that you'll have sorry, that will pick a king off the first draw here.
0.0769%.
I see. How did you find that? What was your fraction you put in there? What's your fraction? 452 reduces to 1 out of 13. 13 cards in each suit. That makes sense. One of them's a king. So if I'm looking at the mean number of choices to pick a king, it should be about 13, right? It should take about 13 cards. Let's see what we get. 5, 3, 8, 6, 10, Jack, Queen, 8, Queen, 8, 3, Ace, 10, 6, 4. This is backfiring. 9, 6, 5, King.
There we go.
Yay.
All the kings are on the bottom, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that one took 19 cards. It took a little longer than we predicted because the mean would be based on the probability, right? There's error from that. So just a little basics on how we create or find probability. It's the number of desired outcomes. There was 4 I wanted out of the total possible 52 cards. Okay, so just if you know that bit about probability, you're okay. If you want to learn more, you can check out all my Unit 2 from Unit 4 from last year if you want. Okay, so SRS. For SRS, we have to use a random number generator. So if you go to Edmodo for today, you're going to find this guy here. Okay, we'll make a new one for today. It's a random. This is horrible. So a random number generator is really helpful because even if I ask you to pick a number from 1 to 30, everyone has preferences, right? Everybody, one person's more likely to pick odds or evens. There's little things that we don't observe until I were to ask you, 2 times a year for half your life. Then you'd see your, predictability. You'd have to forget what you said. So let's go with random numbers. Let's see. Let's just do 12. Which month in the year I'm going to see who has birthdays? So we'll go calculate. So calculate. False. Optional. I don't need to do that. Those aren't our numbers. Okay, so this was supposed to be real quick. Hey, this is how you find a random number. 1 to 12. Let's do that. So if I need to pick the month to see about, I don't want any duplicates, and I calculate. And here's what I would do. So I would ask about the students with birthdays in February, July, May, and so on, right? That's a way to get perfectly random numbers. Now, the reason I wanted to show you this is part of this method, like I put, how do you find SRS? It's when you have the time to number every possible outcome. If it was all my students, every one of my students would have a number. I'd go up to 171, right? Then use a random number generator to pick which item. That is the most random way to do it. Okay, you don't always have that much time. So tomorrow we're talking about other options with that. But when you find using SRS, that's going to be completely random. Now, what is a simulation? Where have you heard or seen simulation before? What is that? What is a simulation? It's what?
Oh, it's the Matrix. But
The Matrix. The world is a simulation. I love that movie, so thank you for bringing it up. We're looking for something different. What else? When do you see a simulation? No ideas? Okay. Yeah.
bull riding things at bars.
Okay. So like a simulated bull riding. So it's an event or something that mimics the real life experience, right? It tests the probability of events in real time, but you don't have to go and get on the bull. That's perfect. Real bull. Those things can hurt you though. If you wanted to do a simulation to prove, is flipping a coin really 50% tails and heads? A simulation this is 50%. It's kind of more of a cognitive stat because there's one of two choices, right? It's mathematically 50%. Using a simulation, how would we prove that? How many coins would I need to flip to get a true simulation here? Or, you know, would it be very few or very many? Yeah, at least 100. If I flipped 8 coins, would that be enough to make a simulation on coin flipping? No. You need way more. You need way more coins. So we're talking in the hundreds, maybe 1,000 coins. And then you would see it wouldn't be perfect 5,000, 5,000. It would be, you know, plus or minus a certain error, right? But that's all a simulation is. And I'm going to pull this down one more time. I want to point out 2 things here. They're kind of interesting as well. Hopefully they come up. So one news source that I kind of like, and it is just barely slightly leaning left. So I will fully disclose that. And I'm going to show you a way to see about media sources as far as left or right slant. Okay. This is called 538. 538 is put together by this guy, Nate Silver. He's the editor here. And everything is based on statistics. Not just statistics, but simulations. So this is the forecast for the race at the House in November, a big race. 5 out of 6 chance that the Democrats will be able to take control. This isn't perfect, but what Nate does is he takes 10,000 simulations of all the variables that you can come up with that would change this race. 10,000 simulations. The mean right here, the average is the number of simulations that happens the most. Normal curve right here. Very unlikely that this many seats are taken by the Democrats. Very unlikely that the Republicans take this many seats. And just from this average, you can see here's the mean. So it's likely that this many seats would go to Democrats. Now, this isn't perfect, right? In 2016, he had an 80% chance that Clinton was going to win, and that didn't happen, right? So there can be flaws. There can be conditions and variables you cannot assess, but statistics can help you get a forecast. Okay. Just because we're talking about bias, I want to bring up this one site if you're interested. Media Bias Fact Check. It's put together by the Dean of Law School at Northwestern. And what they've done is compile a search engine. You can put in any media source, and it'll tell you if it's biased towards left or right. It'll tell you about how accurate their facts are. I find this really helpful because when I see like something on Facebook or, you know, and it's about a study or a publication, look to see where it's coming from. If it's super far right or super far left, I kind of don't want to know about it. That's kind of fringe stuff. Or at least it better be triangulated or affirmed by something a little more in the middle. So, for instance, C-SPAN. C-SPAN is the most unbiased. So when somebody is... If I want to quote some text or I want to get a transcript or something, I'll find it on C-SPAN because nobody can make issue with C-SPAN. It's the least biased. It's the least biased publication because most of the video is just of the Congress and they make transcriptions of what's said. So there is bias, but there are places where you're not going to find bias, and be able to find that is really helpful. So I hope this site, mediabiasfactcheck.com, is one thing I hope you'll kind of fish around and see what's in there. A bit. Okay. If you want to test it, test some of your sources. Even if I am a little more left of center with my politics, I want to know if an article I'm reading is like extremely left, right? Because I don't want to also bring up things in discussion that are really outliers. Or maybe I do. So know where things are coming from is the biggest first step there. All right. Sample error is less with a larger sample size. Kind of basics from flipping a coin. Flipping a coin, if I have 8 coins I'm flipping, I'm going to have a lot of error. It might not be 50-50. If I do 10,000, yeah, my sample error is going to be reduced because I have more chances to it's going to align with the mathematic part. Okay. So now let's look at this example. You didn't see that. It was part of the blur. You already wrote down. All right, I want you to think of other ones then. Or pretend you didn't see it, and when you answer, make it like it's the first time you saw it. It's your job. 875 students in school. Okay. How would you find the percent that agree with the dress code without bias? Without bias. So first thing, what do you need to consider? Let's do it as a group. What do we need to consider when we're creating a sample to find that parameter for the entire population? What do you think? If we're talking about agree with the dress code, what are some things like it matters if the students are what? I hear whispers. Gender. So, gender. I'm going to definitely have a spectrum of gender here where I'm not just focusing on, I can't just go into the boys basketball team and give the survey to them and say, what do you guys think about the dress code? Because they may not care at all, right? Has to be a mixture of gender. Good. Yes?
Their age and grade.
Good, I like that. Age, grade. Do you think that a senior cares more about the dress code or a freshman? Oh, I like that. Raise your hand if you're a freshman in here. No one wants to. Okay, great. Great non-example, awesome. All right, so every other class has said the seniors will care more because they, buy more of their clothing. If you're a freshman, you might already have, your clothes are bought for you. I don't know. Mom or dad buys it. I see what you mean. Senioritis, they maybe don't care as much. I find that older students, in my high school teaching, the older students have more of a need to express their own personality through dress, so they'll care about it a little bit more. So what else do we need to know? Does dress code ever come into play with like sports teams? Yeah? Like what? Like what? Uniforms? Awesome. You haven't seen that before written on the board before.
Oh, was it on the board?
It was. You got it anyway.
Sorry.
Perfect. Gene, what else? And I'm gonna split them up. That's okay. Race, you said religion. I'm gonna make it race, ethnicity, religion. You didn't say religion. Okay, ethnicity. Any other things that might play into who we're looking with our sample? That might be it. Stretching. Okay. So the sample has to be representative of the population. You want to make sure also you consider the factors and not just look for your sample while ignoring these aspects here. Okay. So basically, we're looking at what causes bias, and that is about it for today. If you weren't in my class last year, again, Unit 4, it's all on Edmodo. Also, what's new with Edmodo is have Trinity putting her notes, which are amazing, on Edmodo. She's going to post them on the same day post. Okay. So if you didn't get that good of some notes, you can go back. It's highlighted, color coded. There's a few in here that have that going on. She just offered to do it, so maybe I'll ask you later. All right, what can we remind the viewers to do? What should they do? They should subscribe. What should old students not do? Unsubscribe, then subscribe. Make fake accounts, I don't mind. Make an account for your dog. I care if your dog watches my videos.
He needs that ad revenue.
I need the ad revenue. Need 500 by the end of the year. Just kidding. Don't go bot shopping. All right. Subscribe. I'll have to figure out the giveaway. It's okay.